Okay, Assalamualaikum. Now I talk about chapter 5, equilibrium of rigid body. Okay, first is 4.1. Okay, condition for rigid body equilibrium. Okay, for example, okay, we have a box, okay, placed on floor. Okay, of course, the box has a weight W. Okay, so now question, why the box stay on the floor, it doesn't moving downward? Okay, it's because we know that the flow exert, okay, the reaction force of what we call the normal force. Okay, so we know that the weight of the box must be equal to normal force. Okay, then that's why this box will stay at the on the floor, doesn't move. Okay, next we try to push, okay, a small with a small force, okay, to the left, okay, to the right, okay, sorry, to the right, and then why this board doesn't move to the right? Okay, so because, okay, we know that if the floor have certain degree of roughness, then the friction between the board and the floor, okay, exert a reaction force, okay, we call let's say F small Fs, okay, friction force. Okay, so this Fs, the exerted force to the right must be equal to the Fs. Okay, if we increase the pushing force, okay, the friction force also will increase. So the F, big F, capital F must be equal to the Fs. Okay, so if you look here, okay, the total forces, if we added all together, okay, either in x direction or y direction equal to 0, then we do understand that the boat will not move. Okay, it doesn't move because what we call in equivalent condition or in static condition. Okay, again, if you look here, F here and Fs, okay, there's a gap here. Okay, with the small amount, with the similar magnitude, but in opposite direction. So we do understand this F and this Fs we create moment. Okay, what is moment? That means this boat can rotate, okay, in this direction, clockwise. Okay, so actually does it rotate? No. Okay, because if we exert the force of F here, okay, actually the normal force will slightly move to the right. Okay, it will move to the right, and then we can see between N and W there is also a gap, and that means this W and N also will produce moment, but it produce counterclockwise. Okay, we're going to study this uh, mechanism in chapter of friction. Okay, actually, so what I wanted to show here, okay, this moment, okay, produced by the natural force, this moment produced by the friction. Okay, so here we must understand that the moment produced by the force and friction force and the moment produced by the weight and the normal force, Mf must be equal to Mn. Okay, so we do understand that this box will not move to the left or right, it will not move up and down, and also it will not rotate. Okay, and the was because the moment of the Mf clockwise equal to the moment of Mn counterclockwise. Okay, So what we can say when we talk about the equilibrium condition, okay, for the object to be in equilibrium condition or in static condition, what we can say the total of forces is either in x direction or y direction must be equal to 0, and the total of moment also must be equal to 0. Okay, this is the two conditions that we can define as the condition of equilibrium. Okay, or from here we can state is the equation of equilibrium. Okay, that's all. What is the condition of equilibrium? Thanks.